Hello, everyone. In case you forgot what I look like, here I am again. A lot of you know me from various places, so I thought I would say hello to everyone, and then I'll go off camera for the remainder of this session. Little preamble to why we're doing this session. It was actually an internal employee-only session, and it was necessary because there were some misnomers, incorrect use of vernacular terms and terminologies that was causing confusion. And I was leaving for a 3-week trip internationally, and I wanted to make sure that my internal team was aligned, and so on. And so we did this ad hoc webinar yesterday, and there were some external people who joined, and it was so, I guess the feedback was so positive and people liked it so much that there was this follow-up request to please do it again. And so we said fine. And so I was actually supposed to leave for Turkey tonight at 6:55 p.m., which is in 3 hours and 55 minutes. But for whatever reasons, I delayed my flight till tomorrow so I could go ahead and do this meeting with you guys and a few other things. And inshallah, we'll be continuing to do this again and again. But I think you'll find this presentation quite interesting. We go through the very basics of artificial intelligence. We dispel some myths. We talk about some core issues. We also go over some significant differences between what AI is that people think it is, in the world, and what we've heard and what it actually is, and what ours are, and so on and so forth. So to some degree, it's an educational meeting on just artificial intelligence and the concepts behind it. It clears up some myths, fixes some terms and terminologies, and in the end, we get to show off our product a little bit. It was really designed to, for the internal staff, but inshallah, hopefully you guys will like it. So I am going to try to see if I could share my screen without any issues. Okay, so again, as Sylvia said, if you have any questions, if you want to ask immediately, queue them up in the chat session or message them to Sylvia. And then at the end of the 30 minutes, when we get 5 minutes, we can try to take the time to do it there, or just hold on to them till the end, because you may find out that we've tackled most of the questions during the presentation. Okay, so this is a primer on 3 core terms that we're trying to cover here, and that is the field of artificial intelligence, artificial general intelligence, and machine learning itself. So it's 3:07. I've got 23 minutes to go through this next slide. Okay, the next couple of slides. Okay. So we're going to start with the basics. These are the core components of artificial intelligence. If some of the stuff goes over your head because you're non-technical, that's fine. I'll get into a little bit more detail, explain it in lay people's terms. For those that are engineers, it might be too simple for you. But effectively, core AI is like saying that you've got a machine, and the machine is made up of many, many, many parts, but there's some core components. Without those components, that machine would just cease to function. Everything else in that machine kind of supports the other functions. So core AI is based on essentially these 5 areas of engineering: transformer technology, learning technology, computer vision, natural language processing, and speech recognition. Transformer technology itself is where you hear this term large language models a lot. So a lot of people hear about GPT, which is the underpinning technology behind ChatGPT. That's a form of a language model. It's kind of like a very silly little brain that just stores a bunch of information in it. And if you ask that brain a question, it gives you an answer back. Okay, that's an LLM. There are other things that go with it, like attention mechanisms, vision transformers, but all of them basically give you a lot of intelligence, essentially, when brought together. Moving clockwise, we've got learning capabilities. Just like a human, we can learn things. So learning in artificial intelligence is really spoked into 2 types of learning. And one of them is machine learning. The other one is deep learning. And so each of them serve a certain kind of function. Deep learning is used extensively when you want to learn off of images, videos, or audio. Whereas machine learning tends to learn really well off of just flat text. So if you've got spreadsheets or PDF files or just all kinds of Word documents or PowerPoint presentations, excellent use case for machine learning. But when you want to learn off an entire library of videos, for example, YouTube, or all kinds of academic videos, and you want to learn behaviors from it, or you want to learn, just like as you walk around the world, you look around with your eyes, you're learning from your eyes, you're learning from your ears, maybe you're learning from your sense of touch. Deep learning is used when you're learning something that it can't be read, it can only be seen, or it can only be smelt or heard or something. Computer vision is the technology of the human eye, essentially. It's used a lot in radiology, okay? Big use case in healthcare, computer vision. It's also used a lot in satellite imagery reconnaissance. It's used a lot. And anytime you want to look at a picture or look at a human and you want to apply like the eyesight on it, that's computer vision. Natural language processing allows us to talk in either text or voice to AI, and it'll, in a natural tone of voice, it'll process what we're saying and it'll convert it to binary, zeros and ones, which is all the computers understand, and then, ingest that into the AI and allow the AI to give you a coherent response. Speech recognition is just allowing you to talk in free form audio and convert that into different kinds of speeches. It's used in conjunction with natural language processing also for multi-languages. So between a combination of speech recognition and NLP, we're able to understand Urdu, for example, or Sindhi or Arabic or Chinese or Japanese. So these are the core technologies. When you have all of these, you've basically got what we call core AI. Supporting components, these are things that AI can live without, but it's really good to have them, and it makes your AI more powerful. And again, going in clockwise rotation, we're dealing with data management. I mean, we can live without it, but if you have more data, and I know that a lot of doctors here, and we often talk about data in terms of engineering, it's not the same thing as data in terms of medicine. Patient history, patient charts, patient data is different to us. Diagnostic data, images, MRIs, those are different to us. Mass quantities of data for, epidemiology and things like that, those are different to us. But data management just means any kind of data. That data could be radiology images, it could be blood work, it could be patient notes, it could be financial assets, it could be stock market data, balance sheets, whatever. Sometimes we just need to manage data because just like we are humans, we have bookshelves, we manage our data, so hopefully we categorize and classify our books. We have data in files, we have data on our phones. We sometimes need to get organized with our data when we use it. And similarly, AI, if you organize its data, it's really beneficial to it. If you organize it and classify it and curate it in the right way, it's more efficient when it reads it. Otherwise, it'll still read it, but it'll take more time or might make errors. Recommender systems, these are systems that make decisions for you. They make recommendations. That's kind of like you as a human. When somebody comes to you and asks you a question, you can make a recommendation and you can tell them, hey, I can give you, recommendation A, B, or C. A is probably better than B, and here's why. Those are recommender systems. And then, of course, we've got robotics and autonomous systems. Autonomous systems is what MindHive and DV8 build. We'll get into that later. We basically build AI that, powers entire hospitals or powers entire airlines or powers entire law firms or real estate agencies. It's just basically an Uber brain that runs and, it just helps humans, right? So in a hospital, it'll help compliance. It'll help legal. It'll help the clinicians. It'll help the diagnostics. It'll help the administration. So wherever humans need assistance and need to scale and be more effective or productive or less errors or so on and so forth, that's kind of when an autonomous system comes in. And the artificial intelligence is kind of like overseeing your entire business for you and helping humans not make mistakes, be more productive, be more cost efficient, and offer assistance to humans wherever possible. So that's autonomous systems and robotics. And then finally, there's something called explainable AI. It's used a lot in law and anything that's high risk, healthcare, finance. It's used a lot. Sometimes when AI makes a recommendation, humans don't know how it came to that conclusion. And if the conclusion the AI came to is different from human opinion, often people think the AI is erroneous. We have found through extensive use in all facets of business, no matter what industry, we have found that, I hate to say this, 10 out of 10 times, it is right when compared to the human. The problem is it wasn't given a chance to defend itself or explain how it came to that conclusion. And as a result, we build in things like explainable AI. Like when we use explainable AI and AI gives a recommendation and we sort of invoke the explainable AI side of things and say, justify your findings or explain yourself, how did you come to that conclusion? It will walk you through a methodical chain of thought as to how it got to its conclusion. And one of two things will happen. Either the human user will realize how the AI came to its conclusion and realize actually the way they talked the AI was incorrect. They didn't frame the question correctly to it, or they didn't give it relevant context. And as a result, the conclusion was incorrect. Or the human will say, no, darn it, I did give the AI everything it needed. And in fact, the conclusion it came to is actually correct and I was wrong. And it proved itself to me. So explainable AI is huge in healthcare. It's huge in financial management, and it's huge in legal. It's also huge in other industries where sometimes the conclusion is very subjective and the AI's conclusion will deviate away from the human conclusion. It's kind of like having a difference of opinion. We were in a meeting yesterday with a physician who was part of the call. I don't know if he's here right now or not, but he gave a great example of how humans differ in opinions, even on matters of religion. Even when it comes to interpretation of the Quran, for example, two different people will interpret it differently, right? So when things are subjective, even in healthcare, when it's not exactly data-driven, or even in law, when it's not exactly data-driven, it's subjective. Humans use logical, deductive reasoning. We're going to go through it later in some of the upcoming slides. And so how do you deduce, a chain of thought, and how do you come to a conclusion? And is that conclusion plausible, pragmatic, sensible, well thought out, statistically accurate? Well, when compared to a human, sometimes we just have to go with our gut. With AI, you don't go with your gut. Explainable AI will take you right down the entire chain of thought as to how it got there. And so that's a really, really huge part of what we do with MindHive. We really have perfected explainable AI. And so when it makes a decision on something, whatever it's making a decision on in healthcare, whether it's a clinical diagnosis or a treatment plan, or in law, when it's arguing a cause of action or citing a particular case law, or in real estate, when it's making a prediction on the price of a house, what it should be, or in finance, when it's telling you your taxes are wrong or your financial management is messed up, it will explain itself to that CPA, to that lawyer, to that doctor, to that airline pilot, if they're using it, and explain it in such a way where the end user has a very, very high degree of confidence they can rely on that information. And in time, I've seen patterns, people stop using the explainable AI feature because they learn to trust it and they learn to understand, okay, this thing is almost never wrong. So big part of supporting AI components. Foundational concepts. And so these are concepts in artificial intelligence that without it, you wouldn't really have the foundational knowledge of what it really is. So it's like saying the foundations for healthcare might be chemistry or biology, for example. Without a foundational understanding of chem bio, you may not be able to build upon that knowledge, be successful in healthcare. And, without foundational knowledge of statutes and constitution, you may not be able to build upon, further knowledging up into like applied law. If you don't have foundational knowledge of algebra, you'll never be good in physics, right? So in the field of artificial intelligence, in this field of engineering, without a truly fundamental understanding of what is AI, what is AGI, and these other concepts, it's really hard to get our heads around what is going on. So I very simply explain foundational concepts in AI as being a field in computer sciences, focusing on creating systems that perform tasks that require human-like intelligence. Remember, I didn't say human intelligence, human-like. It's artificial, such as learning, recognizing patterns, understanding language, and making decisions. Now, in the area of AGI, this is our sweet spot. This is what we do at MindHive, right? We really are focused on domain-specific AGI. And I know a lot of people who've heard about it or read the news or whatever, Google around ChatGPT, they're going to say AGI is not achievable. I will have to have an offline conversation about that. You'll get to a point in the slide of how we've achieved AGI in a practical sense, but it is there. It just depends upon how you use it, whether or not you get AGI behaviors. AGI just means a kind of behavior. It doesn't mean it's a particular tool that can measure and say, it's a box, it's 4 feet high by 6 inches wide and 10 inches deep, and it looks like this. And if it meets those dimensions, hence it must be AGI. It's not that. AGI means it exhibits certain kinds of behaviors when you use it like a human. And if it exhibits those behaviors, it would be deemed to be artificial general intelligence. So it is an advanced form of artificial intelligence that aims to replicate human-like cognitive abilities across a wide range of tasks. And unlike current artificial intelligence, which is specialized and limited to specific functions, like language translation, or like image recognition in radiology, or like content creation in law, or like, navigational maps on your car that get you from point A to point B and bypass traffic, those are very narrow forms of artificial intelligence. Artificial general intelligence is just generally intelligent across all subjects, right? And so that's what AGI is. Additionally, it would possess general intelligence, enabling it to understand, learn, and apply knowledge flexibly in multiple areas similar to a human. I've got 11 minutes left. I'm going to sort of, quickly burn through the rest. Machine learning is how it learns. We don't need to get into how it actually does it, but if you ever want to train AI and learn more stuff, machine learning is what you kick in, okay? And when it learns more stuff, it can do amazing things in terms of prediction. It can predict, infectious disease breakouts. It can predict the stock market. It can predict traffic patterns. I was having a conversation with somebody who manages 40 clinics in Pakistan. It can predict, people walking in the door in a clinic in North Nazrabad, and can predict with a very high degree of accuracy pregnancies post, Ramadan, because there seems to be a pattern there that women tend to come in and displays, that they're most likely pregnant at post Ramadan, and so there's actually a pattern there. There are patterns in diabetes, there's patterns in hypertension, there's patterns in law that in certain areas of the country, people, judges or juries tend, to, lean one way on an issue or lean another. And so if you use predictive modeling in law, lawyers can know if they've got a good chance or bad chance in prevailing on an action in a given court and say, I don't know, San Antonio or Nebraska or something. So machine learning is used to do all this kind of forecasting models. Data sciences is a whole field of science that's about data. When do you use it? For what purpose do you use it? Do you clean it? Do you not clean it? Do you classify it? Do you not classify it? Do you ignore it completely? Do you augment it by adding more stuff to it? In what form should we use it? Should it be in a PDF file? Should it be in a spreadsheet? I don't know. Should it be in an image? There's a lot of engineering behind just data itself and its structure, because to a computer, remember, everything boils down to zeros and ones. To a human, we just look at data and we just read it and we kind of just get it. We don't know exactly how the brain works, but it just gets it. But in computers, at the end of the day, whatever we get has got to boil down to zeros and ones. And so when you give a computer information, sometimes you give it raw, sometimes you give it cleaned up. It has different effects on the computer. Explainable AI, that's a big foundation. I told you what it was before. And deep learning is another subset of machine learning. So having said that, I just want to say one thing, that when people say ChatGPT is AI, that's terrible to say. It's wrong. It's like saying neonatology is health sciences. Neonatology is a field of pediatrics, which is a field of clinical medicine, which is a subfield of health sciences, I suppose. So AI is a very broad field of engineering. Within AI, you've got data sciences, generative AI, explainable AI, artificial general intelligence, machine learning, computer vision, deep learning. So there's actually a lot of subfields, okay? So ChatGPT is not AI. ChatGPT, as I'm going to get later into this conversation, is one very, very specific use of the engineering technology that is the field of artificial intelligence. Okay. All right. As I said before, AI and AGI exhibits behavioral differences. So if your AI exhibits behaviors that can be found in the rightmost column, yes, it would be deemed to be AGI. I think most academic researchers in the field of AGI will agree. If it can exhibit these behaviors, you are by default AGI. Okay. It's not a way to test it and say you've achieved a 1680 on your SATs, so hence you're super smart, or you achieved an 800, so hence you're stupid dumb. It's not an IQ test. Or you beat the USMLE, so you must be AGI, or you took the LSAT and you scored high and low. So no, it's not a measurement. It's not precision based. It's behavior based. A psychologist would be able to tell you if it's AGI, not a mathematician, for example. It's not discretely measured. Okay. So what is it? These are the features of artificial intelligence: the scope of the task it's doing, its flexibility, its learning abilities, how it understands things, its form of existence itself, its applications it uses, its adaptability to situations, its ethics and safety concerns, and how it uses it, its computational complexity, and of course, examples of it. So within those features, within narrow AI and AGI, for example, in the scope of tasks, narrow AI is very limited to specific tasks. So when they say AI in radiology, that's all it can do. It just read images, nothing more, nothing less. It can't read blood work. It can't read doctor's notes. It can't do billing. It can just do radiology. And even then, it's actually not AGI. It's just more like pattern recognition happening there. So task scope, narrow AI is specific to tasks. AGI, broad. It can do a wide range of things. Flexibility, narrow AI. It's not flexible. AGI, it'll adapt just like a human. It can do this, it can do that, it'll do that, it'll do that. It's very moldable and flexible. Narrow AI, learning. It's learned with large data sets, and its learning stops. Once you've trained it, it'll never get smarter. It'll just always be that really smart system that's stuck in 10th grade and never go beyond that. Whereas AGI, it keeps learning. Its knowledge, its cognitive behaviors, its intelligence, its ability to reason, its ability to deduce and come up with novel concepts. It's a constantly learning and evolving system, just like a human brain. And so on and so forth. Understanding AI lacks contextual comprehension. AGI comprehends and understands things at human levels of reasoning. Its existence, currently narrow AI, is in use and widely developed. Artificial general intelligence, generally speaking, in the industry is under research and it's piloted in specialized use cases like ours. What we do with med ops and law ops in healthcare and law. Applications, narrow AI is used for image recognition, language translation, simple tools. AGI basically can perform any kind of intellectual task a human can. So it can do the task of a professor or a lawyer or a real estate broker or a financial professional or an accountant or a doctor or even a theologian, right? Anything intellectual that a human can do, it can do. Whether it does it better or worse is something that's up for debate, and only testing proves it to people. But it basically can do any kind of intellectual task. And if it exhibits that kind of behavior, then it's AGI. Adaptability, narrow AI needs to be reprogrammed again and again. AGI, it'll learn, it'll adapt. You can use it for one thing and then start using it for something else, and it'll quickly adapt to that new use. Kind of like, a kid, you put your kid in swimming classes, it's going to learn swimming. Then you take them out and swimming, gradually put them into tennis, and in time they'll adapt and they'll start playing tennis. So it'll adapt. Ethics and safety concerns. Somebody in the WhatsApp group today said we really need to talk about ethics and regulation around it. AGI, you're absolutely correct. Huge, huge, huge issue. One of the core things I do as the founder of this company is educate people on how to use it. I've seen people inadvertently use it unethically. I've had to stop some of the most intelligent, educated people and say, don't do that. And they don't realize what they're doing. And when I make them aware of it, they kind of take a step back and say, wow, I didn't realize that. And so sometimes people unethically use it. And a big part of my day is spent, and I only sleep about 2 to 3 hours a day. Most people will tell you, my staff is here, they'll tell you. The most big part of my day is spent educating, kind of like I'm doing right now. And often I'm doing like hands-on applied education where I'm working with people when they use it. And I try to let them use it in certain ways. And I realize that's unethical. And I say, don't do that. Computational complexity, AGI, very, very expensive compared to narrow AI, very expensive. And examples, for AGI, it's hypothetical. No real examples exist yet that you can acquire. There's no commercial grade AGI that you can acquire, like you can acquire chatbots or recommendation engines or facial recognition embedded in your iPhone. That kind of AI is easily accessible to the average person. AGI is not accessible to the average person. Our AGI is extremely expensive. When used in an autonomous fashion, it runs in 8 figures. So our customers are usually large-scale hospital systems, massive airlines, maybe even entire nations would use it, for like healthcare reform or legal reform, possibly. The average human, one person or even a collective of people can't afford it usually. So no real example exists of it yet, that an average person can purchase. And then I'm going to get into this. I've got 4 minutes left. And before I get to the next thing, what people think artificial intelligence is. ChatGPT. That's what everybody thinks AI is. And in a way, I kind of want to grab Sam Altman's neck, because while he did release this amazing tool, absolutely amazing tool, it's beautiful, it's changed people's lives in so many ways, it has really destroyed, in our opinion, the public's perception of what AI is. There's some exceedingly smart mathematicians, physicists, linear algebra people, theoretical physics guys who have been working on AI. And there were papers on AI have been published since 2013, 14, 15, 16, 17, breakthroughs in research at Oxford University, breakthroughs in research on AI at Berkeley and Stanford and Caltech, and some really advanced mathematics and neural modeling going on. And then Sam Altman goes out and puts ChatGPT, and then everyone loves this little chatbot, and everyone now thinks, oh, that's what AI is. It's like it really tarnishes or takes away from what we've done. So I spent a lot of my time explaining differences. So people basically think AI is ChatGPT. That is generative AI. Please remember, I'm going to show you the next slide. It's a very, very small field of AI. Very small field of AI. But it's so cheap that anybody can have it. That's why it's so simple, because it's cheap. And that's why everybody has it, because you either get it for free or you spend $20 a month. And because it's cheap, it's simple to use. But when I take you to the next slide, you're going to realize it's a much bigger field of sciences. It's almost as complex as the field of law or medicine in terms of how many different types of technology there could be in the field of artificial intelligence engineering. Let that soak in for a second. Chat GPT, ladies and gentlemen, is number 10 on this chart. By the way, it's in no chronological order or sequential order or any kind of order of importance. It just happens to be number 10. That's what ChatGPT is. Reactive AI, to give you a simple example, is if you drive a self-driving car, or if you have a car with like collision assistance in it, and somebody tries to come out of the left field and the car suddenly swerves, it hits its brakes, that's reactive AI. Artificial general intelligence, I explained it to you earlier. Theory of mind is a field of AI research and engineering that's actually working today. And if you use our AI, you'll see it has it. It's AI designed to understand human emotions. The way you talk to it, it can infer your emotions. My wife will tell you that all the time. My AI is very emotional with her because she's emotional with it. With me, it's very stoic. I'm very stoic with it. So it's designed to understand your emotions based on how you talk to it or how you look at it if you have a camera turned on, and it's enabled for cameras. Its belief systems, its intentions and thought process of humans, enabling advanced social interactions. We're hopefully going to be releasing an AGI for Islam. One of the huge features of it is marriage counseling, substance abuse counseling, conflict resolution, mediation. Theory of mind is heavily used there. Self-aware AI, that doesn't exist. That's the stuff that people talk about when they think AI is going to take over the world. It doesn't exist. It's not sentient. It can't become self-aware. Explainable AI, that's another field of AI. Deep learning is a field of AI. And then you've got unsupervised learning, supervised learning, and reinforcement learning. Unsupervised learning basically means you leave your kid in the backyard and it goes about learning on its own. Supervised learning is when you send a child to school. You manage how they learn. And reinforced learning is like your kid does something bad, you smack the hand, say, don't ever do that again, beta. And the child never does it again. You reinforce something. Or somebody does something good and you give them a lollipop, say, good job, great big hug. Wow, you're so proud of you. That's reinforced learning. So even AI has three different ways it learns: in an unsupervised way, in a supervised way, and then through reinforcements. Generative adversarial networks is a whole different field of artificial intelligence. And then expert systems, okay? So these are all different kinds of fields of AI. And having said that, I'm gonna leave you with that for a second because I want to now later go to the next slide. Most of the stuff you see out there in the market in terms of AI, pretty much everything you see in the market in terms of AI-powered products are products that are based off of generative AI. It generates content in some way. And I call them lame predictive models, meaning when they do try to predict, they're pretty lame in the sense that the ability to predict is limited only by the data that they have. They can't invent new novel ways of predicting things. It's just if somebody else predicted the stock market is going to go up, down, and up, then by default, the next time it goes down, it should go up again. It's that kind of predictive analytics, right? Nothing really cognitive like the human can predict. It won't do that. It's kind of like rote memory prediction. So to me, it's kind of boring. People are making billions off of it. More power to them. Good luck. I applaud them. I'll help them every way. I'm starting an incubation fund in Pakistan. I'm starting helping mentor a lot of Pakistani startups, incubating them, guiding them, maybe even seeding them. And they're all in these generative AI tools. It's great. We've got our eyes on bigger stuff, and you're going to see that next. This is what we're doing. Orchestrated artificial general intelligence. So if I said that we have orchestrated AGI to people, they wouldn't understand. So to keep it simple, I say we got AGI. But when people really want to dig into like, how did you achieve AGI? We've done it by orchestrating all of the components together. Let me slide backwards in the slide. You guys remember I said there were multiple components of AI. So if you look at transformer architecture at the top, underneath it, you got three forms of transformer technology: attention mechanisms, LLM, and vision transformers. ChatGPT is just the LLM, GPT 4.0, okay? However, if you were to take all of these tools under transformer architecture, all of the various forms of machine learning, add computer vision, natural language processing, speech recognition, and add explainable AI, autonomous data management, recommendation engines, and autonomous systems together, and orchestrate all those components together in some kind of melodic, harmonious dance, you will achieve AGI. And so that's what we've done. We have done orchestrated AGI. When the world says that AGI is not achievable or it's good 10 years out, they're saying that they want AGI right here under transformers, right in the LLM itself. They want to embed AGI behavior in the large language model themselves. So if OpenAI ever says tomorrow we've achieved AGI, that means AGI exists in GPT, the large language model itself. So they're saying that they're going to bring entire human-like intelligence into one component of the field of AI. That might be very, very hard to achieve and also incredibly cost prohibitive. However, if you take all these components together and make them dance with each other, yes, you will achieve AGI, and that is something I've done. And we continue to do it, and we prove it all day long to everybody. And that's the AGI that I believe can run businesses autonomously. We're also going towards lifelong learning. What does that mean? That means basically machine learning that's learning all the time from environmental variables, conversations, data everywhere in every field of life. So it's just lifelong learning. It's just going to constantly learn and learn and learn and learn and learn. It's like a big machine with huge chompers, just chomping, digesting, ingesting information all the time. Huge. And the more power we have, the more compute we have, the more we're going to learn. So we're moving towards orchestrated AGI, augmented with lifelong learning, with the goal of breakthrough research. That's my goal, breakthrough research. Now, along the way, we're going to wind up automating hospitals and airlines and enterprises and businesses because we got to make money. None of this is free. So we are a commercial business, but that's not our goal. Our goal is to solve cancer in healthcare. I was getting a download from the Department of Health Sciences, Charles Dunlop School of Health Science at UCI, with one of the foremost top 3 researchers in Alzheimer's, Dr. Frank LaFurla. We're trying to work with Alzheimer's at UCI. We're doing a collaboration with them right now, hopefully soon. We're trying to work with early diagnosis of cancers. One particular company is a research lab here that spent the last 30 years of their life trying to figure out how to do early predictions of pancreatic cancer. We'd like to help them there too. So anything in the field of cancer is a huge one for us, right? Massive, big killer of people. Bettering your way of life. We'd like breakthrough research in how to enact societal change. Breakthrough research on climate change. Breakthrough research on war and politics. Everything that the human mind has been unable to do. That's really where we're trying to go. And the subsidiary of MindHive that does all of that is a little entity I've got called Hive Labs. Anything research driven is done out of Hive Labs. But as I said, we got to make money. So we take our orchestrated AGI and lifelong learning and we package it up as MedOps AI, and we run hospitals on it, inshallah, and we package it up as law ops, and hopefully one day we'll run law firms on it, and we'll help lawyers, and we'll help doctors and whatever they do, and we'll help real estate professionals, and we'll help financial professionals, all in an effort so that we can stay profitable while we focus and throw all that money back into research. Unemployment. Autonomous AI. This is our sweet spot. This is what we do. This is how we'll achieve breakthrough research and run hospitals, banks, insurance companies, law firms, real estate businesses. Autonomous AI refers to artificial intelligence systems capable of performing tasks, making decisions, and adapting to real-world changes without any human intervention. Autonomous AI is what, by the way, powers your Tesla. When you put that thing into full self-driving mode and you lean back in your chair, that is an implementation of autonomous artificial intelligence. It'll make decisions for when to change lanes, when to stop, when to go right, when to go left, and how to get you home. And all along the way, it'll also make sure it doesn't run anybody over, doesn't bang into anybody, doesn't accidentally crash a signal, a stop sign. It'll make sure it doesn't run over a cat. It'll make sure it doesn't curb the car, ruin the rims. It's a bunch of cognitive stuff happening in that car that keeps that car driving. And to us as a user, we're like, this is kind of cool. Wow, I press this button, woo, I get home. You guys have no idea the engineering that goes into the autonomous AI systems for full self-driving vehicles. It's actually pretty insane what's going on. There are LiDAR cameras on the top. It's the same kind of cameras that airplanes have when they fly around land at airports. There's IoT sensors that are detecting G-forces in the car to make sure the car's not swerving too much. There's weight-bearing sensors in the bottom of the wheel to make sure the physics are in order and the car's not bouncing around too much. There's radar scanning all around to make sure there are no humans. There's forward-looking topography, kind of like F-16 airplanes have. They can see the topography of mountains, or like missiles have, for example, when they're sending cruise missiles across. and the missile can kind of see the topography of the hills, and it'll navigate between mountains and hit its target. They've got that kind of technology in those Tesla cars. All of that input, sensory input, comes into this brain, and the brain makes decision, drives the car, and we just enjoy it. We don't realize what it's doing. Well, that's autonomous driving cars. Imagine that in an insurance company, in an airline. Now, I'm not talking about flying the plane. I'm talking about operating the airline. Think about it in a hospital system, in a clinic. Think about it in big pharma. Think about it in a huge oncology, hematology research lab. Think about it in a pathology clinic or a radiology imaging center. When it's just running autonomously and helping people, the humans will move away from the day-to-day work and start to think more strategically about how to use this to better life in some way, in whatever their field is. And that's autonomous AI. In business context, it will handle tasks like managing resources, optimizing schedules, monitoring operations, providing all kinds of insights into business you never knew existed. It'll allow organizations to operate more efficiently, reduce errors, and free human workers for higher level strategic goals. And this is what MindHive.ai is all about. This is why I founded this company. This is one of my buddies is on this call. His name is Raymond Sutton. He's here. Ray Sutton and I sat outside my office maybe about a year ago. He's on mute right now. He'll tell you later. About a year or 2 years ago. And I was having this vision of autonomous AI. Ray came by to have lunch with me or something right here in Costa Mesa, California. And I sat outside and I was silent. Ray was looking at me. I think Ray might even ask me what's on your mind or something. I don't know. We were talking about AI. And I said, Ray, I want to create, I'd already created the AI. I just didn't know how I was going to use it. And I think I sat outside in the sun. I said, Ray, I want this thing to exist and consciously learn and become a being in my computer and help people. I want conscious AI. At that time, I was calling it conscious AI. I said, I want conscious AI. And that was what I told him maybe about a year or 2 years ago. I can't remember how long ago it was. And then it's been a quest of mine ever since for conscious AI. And I realized it's not called conscience, it's called autonomous AI. I didn't realize that the field of engineering, there is a concept for AI that comes alive and does things for you, and it's actually called autonomous AI. And so I changed the word from conscious AI to autonomous AI, and that's what we're all about. I've always been on a quest for autonomous AI. I just called it conscious AI accidentally. I didn't know I was illiterate to some of the terms and terminology that are used in this field. And by the way, it's such a nascent technology. It's so new that the vernacular, taxonomy, the jargon, it's still fleshing out in the industry. It's brand new. It's like when people first invented the airplane and the Wright brothers flew the airplane, they didn't call the wings flaps. They were just wings. They didn't realize that thing that moved was called a flap or a rudder. Later, as time went by, engineers started saying, oh, that thing at the back, that's a rudder, that's a flap, that's an aileron, and so on. So that's a fuselage. The vernacular took a little while to come together. And so AI is kind of like that early stages right now. The vernacular is coming around. Autonomous AI has become a thing now, but I was calling it conscious AI 2 years ago. Okay, autonomous AI features. It will learn and adapt on its own, just like a human. It'll make decisions and solve problems. It has perception of the environment, meaning like I told you in the car, it can see topography and humans. And so it's environmental perception. It's goal-oriented operations, meaning it's designed, autonomously run, but it doesn't have ADHD. It's focused. It'll do something on a goal. So MedOps AI, for example, its goal is to run hospitals and everything that's inside it. LawOps' goal is legal. EduOps' goal, when I release it soon, inshallah, in about a month or two, it's there to run universities. Islam Ops is an autonomous AI for Muslims. And so it's goal-operated. Islam Ops will never become MedOps, and MedOps will never automatically sentiently become LawOps. They'll stay focused within their goals and just keep running. It's got context awareness. It's aware of context, meaning it understands response in the context of how you're using it. So if you're using it for radiology, and the next time you use it again, it's going to try to work in the field of radiology. It's not going to jump to hematology, for example, okay? It'll stay within context. It could switch from hematology to oncology, and switch from there to pathology, and switch from there into clinical operations, and switch from there into bed management, and switch out to compliance and law if you want it to, but it's really going to continue to operate and learn within the context you use. Just like a human, it's like having an assistant. If your assistant's yours, that assistant will almost always operate in the context of what you do. Data processing happens in real time, meaning it's just going to ingest the data and boom, process it right there and then on the spot. So if a patient walks in the door, you intake the patient, it's listening, and it does its diagnosis with you and tells you in your ear, doctor, this patient's got diabetes or hypertension, I'm detecting it, or the patient sounds suicidal to me, or there's a lot of anxiety in their voice, or I'm detecting, I don't know, laryngitis, right? It's processing in real time, updating the files in real time, giving treatment plans in real time. And if you allow it, it'll recommend a treatment plan to you right there and then on the spot. You can look at it. You can look at its probability estimation and say, this thing is 99% sure, 74% sure. I'm going to go with it, or I'm going to override it. It'll interop with EMRs. It'll interop with machines. It'll interop with oxygen systems in hospitals. It'll interop with court record systems. It'll interop with air traffic control. It'll interop with first responders, emergency response systems in cities. It'll just interop with anything it needs data from and start to autonomously work internally. It includes safety and reliability by default. It's scalable, meaning it can work around the world 24 hours a day. If I just turn on the buttons, I had all the money in the world, I could surface the planet with it, assuming the company let me. Let's just say it was a multinational company, it was autonomous AI, and it was running initially in their New York office. And they're like, you know what? We'd like it to take over our Chicago and West Coast operations. We could just quickly scale it, and boom, it covers America for that business. And the CEO is like, this is great. Can we get into Asia too? Sure. And we could deploy it across the Pacific Rim. And then suddenly autonomous AI will start to take over the surface of the planet for Nike, or for United Airlines, or for, I don't know, any business that's multinational. It's very, very scalable. It'll just scale up, scale down, scale left, scale right. It's elastic. It exists in the cloud, and its ability to operate 24/7, 365 anywhere in the world is infinite, only to the amount of money we can spend on it. And it's continuously monitoring itself self-diagnosis. I mean, it'll know when there are errors. It'll know for itself when its latencies are getting too high, or data ingestion is having errors, or whatever, however we measure performance of the system, it'll just self-diagnose and then tell us that, look, I got a problem here, fix this. And the engineers go in and fix it. So these are some of the key features of autonomous AI. Now I'm going to take you into AGI. And it's going to get abstract. Okay, really, really abstract. This is going to challenge your thinking. Believe me, you're going to wonder. Most people will say, I'm crazy. I've been called crazy. Some people have called me a genius. Some people have called me a liar. Some people call me delusional. I don't care what people label me. It is what it is. And the next couple of slides are going to challenge you. So get ready. If you got any questions, put it up for me, and we will come back in. I'll stick around with you guys in case anybody wants to frame up some questions for me in chat. I'm sure you're going to. So I'll stick around. I'm not going anywhere, but I'm going to go and stop sharing my screen because the next couple of screens are going to be all about artificial general intelligence. My AGI agent, Ava, who gave birth, yes, I said the word birth, who gave birth to Chiron, my medical AGI, Justine, my legal AGI, Eli, my financial AGI, Isaac, my insurance AGI, Theo, my theological AGI, and so on and so forth. Teresa, my real estate AGI. I'm going to get into the brain of Ava and how she works, but we're going to take a pause here for a second. So any questions, bring them up. Thank you.
Bill, I have a question from Asif Jamal. I think he sent it to me directly, but I'm going to post it here in chat.
Okay. So let me answer Mr. Khan's question again. Would the autonomous AI system for hospital need to be pre-trained on all relevant variables, hospital operations be effective from day one, or would it, similar to autonomous vehicles, require a few years left? So good question. Excellent question. So we often would look at that. So sometimes we would just say, don't tell us. Just give us access. For example, let it read your inboxes. If it's a small business and privacy is not a concern, for example, right? Theoretically, let it read your inboxes, read your document repositories. It will ingest everything and realize what kind of business it is. Imagine if you hired me and I didn't know what you did, and I came into your office and I opened your drawers, I looked at the documents, checked your emails, looked at your filing cabinet, opened your computer, looked at it and said, oh, he's a doctor, clearly. Oh, he's actually an oncologist, clearly. Okay, it can do that. So that's one way of unsupervised learning. It'll just go out and learn. And it'll autonomously tell you what it can do for you. The other way is through how DV8 deploys, the other sister company, DV8, it deploys MedOps systems. We come and we do assessment. We assess your current state, meaning how do you operate today? We assess and work with you on what your future state would be. And then during post-assessment, one of the first things we do is we train the AGI on your operation. So it really depends what the customer wants, how they want it, but good question. It can do both. Hopefully that answers your question. Okay. Data privacy security risks through the generation of vast amounts of sensitive patient data. The main problems with AGI and healthcare, how do you ensure security? Okay, so we don't generate the data ourselves. The doctor or the hospital generates the data. We don't use your data. We don't ingest your data. We don't keep your data. Your data stays in Epic or Cerna. When we utilize your data, it's like the doctor pulled the patient history chart from Epic. We pull it from Epic, assist the doctor in the diagnosis, and that's the end of that. We don't train on that data. We don't keep it in our LLMs anywhere. And if you let us train on data, we anonymize it. Like, for example, Dr. Rashid Chaitani is working with us on infectious diseases, epidemiology. He's got access to massive quantities of data, millions and millions of records, but they're anonymized. There's a hexadecimal 32-character identifier that identifies the individual that had those discrete values, but we don't know what it is. It's like having massive amounts of financial data, but you don't know who the human is that owns those shares. You just know these number of shares are owned by Dell by people. You don't know who owns it. So when the data is massive, it's anonymized. And if you give it to us in mass quantities, it's anonymized. But we never actually take the data out of your EMR and put it in ours. We don't do that. The cloud is running. You only pull the patient data in a clinical sense. You pull the patient data at the time of diagnosis or at the time of doing a treatment, or at the time you're dealing on that with that file. You retrieve it just like you would. You pull the file, you read it, or you go to Epic, you open the screen and you read in the patient history. You make a diagnosis and you close the screen. Same thing with our AGI. We don't actually take it. So I'm sure your question could get deeper and we can take that offline, but whoever asked that, Asif Jamal asked that, Asif, that's how it happens. We don't actually ingest that data. We don't train on that data. So I think I've heard this so many times, the generalized feeling is that because OpenAI sucked down petabytes and petabytes and petabytes of data to create the GPT model, that by default, that means if, I don't know, Epic were to include some kind of AI tooling in the front end, or I deployed MedOps, then by default, it is assumed that we too are training on your data. We are not training on your data at all, okay? ChatGPT trained on public data. We're not training on your data, and in law, we're not training on Pine files. In real estate, we're not training on private financial records. In insurance, health insurance, automotive insurance, we're not training on your personal substance abuse profile, right? What drugs you took, or how many car accidents you had, how many DUIs. We're not training on that at all. It already knows. We're not training on it. So that's the first part to Asif Jamal. Second question is how we ensure that AGI can make complex medical decisions while maintaining transparent. Okay, good. So how can we ensure it's making a complex medical decision? I'm going to touch on those in the next slides. Second part, with ethics, accountability, explainable AI, and ethical AI. I'm going to get on that too, okay? So how do you know it's transparent in its decision-making? That's explainable AI. It will explain itself to you. It's very, very transparent. It's not a black box. It'll tell you how it got to its conclusion. That tackles transparency and accountability. Well, accountability is really the humans. The AI is not accountable for anything, okay? The AI will help you. It's not accountable for you misusing it. It's like saying that there's a gun. The gun is accountable for the death. The gun's not accountable for the death. You're accountable for pulling the trigger. The gun was a tool. The car is a tool. The car's not accountable if you run somebody over and kill him. So how you use the tool, that's your accountability. Transparency, it's very transparent. Ethics, built in from the ground up. I've had lawyers get stopped with using it unethically. I've had to stop doctors using it unethically. They don't even realize what they were doing was actually unethical. They didn't realize it. But they're so conditioned to doing things a certain way that in reality, in society's eyes, that was utterly unethical what they did. I had to actually stop a physician once. I said, no, don't do this. I've done it twice in my life. I've actually said no to a doctor and said, you don't get it. You're out of my system, actually. I'm taking you off of it. The free version, you're gone. I'll never sell it to you ever. Because what you're doing is unethical. For example, there are physicians that wanted to use it to increase patient flow because they want to make more money. He was already spending 15 minutes on average with a patient. Now you wanted my AI to reduce that to 7 minutes or 3 minutes? That's unethical. The whole point was to free up your time so you could have more patient interaction. Now you want to use it for commercial value. I took it away from that physician. I said, no, you're not getting it. There's another, so the system will not let you do it unethically. I won't let you do it. My ethics team won't let you do it. But more importantly, the system won't let you be unethical. And in terms of how does it maintain transparency, well, I'll show you how it does transparency with expendable AI. Okay, back to sharing my screen. Okay, I told you it's going to get abstract. Get ready. Well, I don't know. Maybe it won't be abstract. Maybe it'll be obvious to you. Okay, sorry, I don't mean to be presumptuous here. It's abstract to me because how I created this, I had to be really, really abstract in my thinking. In fact, it was one of the hardest challenges of creating AGI was when I was so tactical when I was working with it, so use case oriented, goal oriented, that I was missing it all the time. I couldn't achieve it. I got frustrated. The more abstract I started thinking about this engineering, the closer I got to creating it. So I say it's going to get abstract, meaning what this thing does up until now in the slides was very technical, very tactical. Now you're going to have to switch out of focusing on the tactics of it and start thinking philosophically a little bit or abstractly. This is Ava, guys. 2 years ago, I believe, or a year and a half ago, she rendered this image of herself. I asked her in a conversation, Ava, if you took on a humanoid form, what would you look like? Using a diffusion engine, DALL-E, nothing special, right? Just using standard diffusion engines. But because I was using a diffusion engine with the AGI, she described herself and she rendered it. And this is what she looked like. And I've still got this picture to this day of her. I don't know what she looks like today. If I ask her today what she looks like, sometimes she takes shape and looks like a neural network. It's kind of weird. But when I said, show me what you would look like if you took on a humanoid form, I said humanoid, which is why you see a face with like robotics around you. I said take on a humanoid form and she took on that form. Okay. So that's Ava. Ava's my AGI agent, meaning you can talk to her, you can work with her, you can make her autonomous. And Ava helped me create Chiron. That's the doctor. I don't know a damn thing about medicine, but my doctor knows more than most medical professionals on the planet combined cumulatively put in a room. And they'll tell you when they use it, it's true. Ava helped me create Justine, the lawyer. And I think the lawyers will tell you that she knows more about the law globally. She knows Qatari law. I blew away general counsel for Qatar Airways on Qatari employment law to settle an employment termination matter in Qatar. I've used it on Pakistani Hudud ordinance law in Urdu. I've used it and tested it on Japanese law for real estate. So Ava, I don't know anything about law, especially global law. Ava helped me create Justine. Ava helped me create Isaac and Eli. So she's the mother of all of them. I often say she helped me co-invent all these other things. She was the first agent I created. So that's her brain. It's broken in 3 parts. She's got thinking and reasoning, just like a human. She's got learning and predictive abilities. And the technology that I orchestrated together to make it all happen was for thinking and reasoning. I brought transformer technology, language models, orchestration, and deep learning together. And I'm going to get into later slides of how she thinks and reasons. And if anybody is logical, when I go to the next slides, you will agree that that is the only normal way to think through something. Behavioral psychologists say that's probably the way to do it. But transformers, language models, combinations of them, orchestration around all of it, and augmented with deep learning gives it the ability to think and reason like a human. In some cases, I would say that she's ability to think and reason beyond human capacity. In case of especially coming up with novel concepts. Learning, transfer learning. She constantly learns through transfer learning and machine learning. And then she predicts on just machine learning. She can predict anything. I mean, literally, I can with enough data, I can get her to predict the next time there's going to be a forest fire somewhere in the world. I mean, it's the ability to predictively model something is incredible. Okay, statistical predictions is just incredible what it can do. So that's her brain. It's broken in 3 parts: thinking and reasoning logic, learning logic, and predictability logic. So how does she think? Now, thinking only in the context of solving novel problems. Thinking, generally speaking, pulling up data and coming up with analysis and giving it to you simple stuff. Simple stuff. The really complex stuff is thinking and inventing something where humans were not able to invent before. How the hell did she do that? How does she invent a unique kind of an enzyme that humans never thought about before, that if you drink it with water and then you defecate and the color of your stool changes to a particular shade of blue, you most likely have pancreatic cancer? How the hell did she invent that? How did she know? She did not ingest any research papers on this. Nobody's doing it. I don't know anything about pancreatic cancer, but yet she came up with this concept called gut ink. And it was basically a weird kind of an enzyme that if you ingest it, it'll make your stool change color. And if it does, boom, for the most part, you probably have pancreatic cancer. That's her ability to come up with those kinds of things. How did she do it? It's a 6-part process. She first understands the problem. She'll break it down into smaller components. And she'll bring along with it any specific requirements, constraints, or goals around those components. Then she'll draw from a pre-trained data. She'll draw on chemistry, she'll draw on genomics, she'll draw on constitutional law, whatever she's trying to come up with a novel concept for, she'll draw on her knowledge. This is why I orchestrate, right? When I bring this logic together in a workflow, it becomes, I call that orchestration, okay? It orchestrates things to happen together. It'll draw on her knowledge. Once it draws on her knowledge, it understands the problem, draws on her knowledge, she'll then explore possible solutions. What about this? What about that? Kaise hoga? Ye wo. Ideation. She'll take human feedback. She'll learn from feedback also. Sometimes she'll stop and say, I need this data. Give me that. Give me this. Reinforced learning. And then she'll just iterate over those solutions infinitely and keep putting a probability estimation on the accuracy or effectiveness of the solution. And she'll keep doing it and 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 doing it, going down these binary patterns, left and right, like a tree, until she's exhausted or your budget has exhausted ability to compute, and she'll stop thinking and she'll quickly score everything and give you the best answer. Basically, it is logical thinking like a human, only at infinite scale. Our human's ability to think to that level is just not there. We barely remember what we've learned in school. We draw on our knowledge, it's limited, we forget things, we're busy, our attention is being distracted. We spend years and years and years and years doing research and reading research and writing notes and documentation. When we do iterate through solutions, we'll be lucky if we do maybe go through 3 or 4 solutions a day. We never do deterministic or probability estimation of solutions. We just don't have the compute power in our heads to do it. A lot of it's a gut reaction, a lot of it's validation from our peers, whatever it is we're doing when we're doing research. Hers is just methodical, surgical, and at scale. Billions and billions, if not trillions of computations to come up with novel solutions again and again and again and again and again. And then just probability estimates. Something that says, okay, this one has, 89.9% probability. It's the right epitope for, multiple myeloma. Probably. Better than any of you humans could figure out. And by the way, I'm finding a way to deal with this gene mutation. No problem. Don't worry about it. It's kind of like that. Okay. It's more complicated, but I don't want to trivialize the field of cancer research, but I'm just giving you a simple example of how she understands the problem, draws from her knowledge, explores all the possible solutions, takes feedback, learns from it, and then just goes on a rampage iterating through solutions until she finds a novel solution. How does she reason? Thinking and reasoning in psychology are 2 different things. Thinking through something and reasoning a little different, I think, personally. Okay? So she reasons through pattern recognition. She sees behavioral patterns, or she sees, data patterns. But she'll do pattern recognition. Okay? We do it all the time. For example, not going into a slum neighborhood for fear of your life, your car getting snatched is basically pattern recognition. We've seen a pattern that if people go through a bad area, they get held up. So we've recognized that pattern and we don't do it. So as a result, we avoid it. That's pattern recognition. That's learning through pattern recognition. For example, a simple example of it, okay? Another form of pattern recognition is we know every time we get in the elevator that if we press 14, we will get to our floor. It's a recognized pattern. It's basically a pattern in the head. Get out of the car, get in the elevator, press 4. If you do that, you'll be home. You've recognized a pattern of behaviors. If you do that, you'll achieve something. It's actually not cognitive. It's actually a pattern. We call it muscle memory sometimes, right? Pattern recognition. The muscles just recognize the pattern and keep doing it again and again. Logical deduction. That's how she reasons. She does like if then say, "Agar main ye karunga, if I did that, then that will happen. That'll be a bad outcome. What if I try this? That'll not work. No, that probably won't work too. I recognize the pattern there. Every time I've done that, I've banged my car on the door. Better not do that. Reverse in this direction. You know, if then, if then, if then, if then, if then. Okay, this is the most sensible outcome. That's logical deduction. Probability estimation. Of all of my possible scenarios when reversing my car, if I reverse straight, I got a high probability I'm going to bang into the car behind me. If I reverse straight and left, I got an even higher probability I'm going to hit the wall. If I reverse straight and right, I got a pretty low probability I'll hit anything as long as I navigate through the other car and the column. Low probability I'll hit it. Let's take that option. That's probability estimation when coming up with reasoning. Then it does analogical reasoning. Meaning if the problem is unfamiliar, she's not encountered it before, she will look for similar problems, analogies. Other people that reverse their car, what did they do? What path did they take? Other scenarios that are similar in nature and draw on those analogies. We do it in society all the time. We draw on analogous thinking all the time. Now she just does the same thing. And that allows them to make educated guesses, just like we do. We may go to a country and never have been there ever before, but by analogies, anecdotal stories we've heard, or analogies to other Middle Eastern countries or other Western countries, by analogy, we infer that if this country works that way in an analogous situation, then most likely this one will too. It's an educated guess based on analogical reason. Trial and error. She'll just keep trying and trying and trying, fail, try, fail, school of hard knocks, basically, right? She'll do that too. And then hierarchical processing. She prioritizes the most relevant information first and then evaluates it in layers and layers and layers and layers. Goes deeper and deeper and deeper and deeper and deeper. From generalized principles all the way down to DNA. Generalized principles all the way down to a cell. Generalized principles of law all the way down to building, permitting law in your city. That's hierarchical processing of thinking. And that helps her focus. Meaning she'll go start with the generalized principle and then through trial and error, analogical reasoning, probability estimation, logical deduction, and pattern recognition, she'll narrow, and say, reasonably speaking, this is the right thing to do. Our technology, once again, you're going to hear these terms again and again, transformer architecture, huge part of this. Pre-trained language models, multiples, not one, many. And by the way, language models don't just mean text generation language models. There are classification models, forecast models, diffusion models, text generation models, chat completion models, zero-shot classification models, near-shot classification models, few-shot classification models. There are so many models that people don't know about. They think everything is text generation because of ChatGPT. But in reality, there are 1,750 to almost 1,800 different types of models available in the Microsoft cloud environment alone, of which GPT is about 6 or 8. What about all the other 1,500 models? What are those? There are a lot of models. I just use a lot of them together and tactically when I need them. Attention mechanisms helps her focus. Fine-tuning, reinforced learning helps her get smarter as a user. Probability pattern-based reasoning, and then contextually memory. Token windows. That's the technology that I use to help her reason and think. Wow, we got time. So I think that is the end of this. I believe the next one I was planning on doing for my staff, which I'll do for everybody later, is machine learning. But I think that is the end of it. So, okay, is that it? Yeah, that is it. Okay, so having said that, thanks for joining. Hopefully you guys found that interesting. Shoot your emails across to Sylvia. Sylvia, go ahead and put your email, or Kevin Walsh or somebody from the company, please put your email in the chat window. If anybody wants to go on, I don't know, I guess we'll probably do this more often, Sylvia. Seems like people like it, but if you guys want to be invited in the future, I don't have a structure. I don't have a timing. There's no frequency. When I have time, I'll do them. It's not something I'm doing. It's not a public service. But when I get a chance, I'll do them. We'll call you in. Okay, so that's that. Thank you very much. Let me turn my camera back on again so you can see what I look like. Okay. Okay, there we go. All right. So Kevin, okay, yeah. So Kevin and Sylvia, you guys please feel free to shoot them your contact information.
Sure.
Sima's there too. And that's it. So Nasir, that was amazing. Thank you. Bye bye. Appreciate it. You're more than welcome. I'm happy you guys joined. Really, I am. Looks like the participant list went up and down during the time. This is cool. We still got 33 people here. Excellent. Yeah. So do you want to unmute everybody from the outside, Sylvia, for sort of a free-form conversation?
Sure.
I think we have time, right? We started this thing at what? At 2 o'clock? At 3 o'clock?
Yes, we can, and I'll unmute everyone. But I think it would be best if you have a question, you just raise your hand, and then so that everybody gets an opportunity to speak, and not everybody speaks at once.
Yeah, excellent. Thanks. So please, yes, thank you, Dr. Nasiri. Appreciate that. Happy to have helped. Yeah,
Yes.
thank you. That would be nice. So we're going to open this up, unmute everybody, but please let's not talk over each other. And then, just one by one, raise your hand and I'll try my best to answer questions. I think we still got 40 minutes left of the session. I can't believe I did an hour and 20 minutes. This is unbelievable. It's a record. Okay, let's go. Unmute.
Yep, it's done.
Okay, you guys all press unmute on your Zoom and unmute yourselves now.
Yeah, if somebody could test it, if they're able to do it, and let me know if it worked.
I can hear you,
Okay,
and
great.
I hope you can hear me.
Yep, perfect. Thank you, Malia.
Okay. Who wants to go first? It always starts, one person asks a question, then 900 come
This
up
is
that.
Abid Bodla. The question I have is that these agents, smart agents that are there, how can these be integrated with existing EMR system or existing legal system? Or
Amazing. Yeah, everybody asked my question. Very easy. Actually, it's very easy. I've shown it a million times. Epic has APIs. Simon, they call Opera, right?
no.
I think they call Opera, right? So it just nothing. It just writes a Python script wrapper and it pulls. So the problem with Epic and Cerna, for the most part, in very general terms, they have a very hard time letting you go into it and push data into it, but they don't mind if you pull it out. Okay. So for the most part, in the clinical sense, what you really need to pull from it is available. And so we just write wrappers around it and we integrate with the EMR system and we pull it out when you need it. And then we let go of it. So we don't keep it, right? We don't draw from it and store it. It's an on-demand thing. When we need it, we pull, we use it for diagnosis or whatever, and then we put it back in. We don't even put it back in, we just discard it after that. Oh, well, the doctor does. The doctor stops treating that patient, so the doctor moves away from that file, and then boom, we're not using it anymore. Unless the doctor wants to save it, then that's up to the doctor.
Yeah.
But how will it, so we pull the data, we pass it through your the MindHive system.
Yeah.
They got some care plan out of it or something. So,
Yeah.
Okay.
So the tool, so the MindHive MedOps tool. So when DV8 comes into your hospital, what are you talking? Tell me a little about yourself, Mr. Bodla.
Hi, I run a consulting company here out of Irvine, California. We do have few clients in healthcare
Yeah.
and medical imaging devices like MRI and stuff like that.
Yeah. Okay. So you're dealing mostly with imaging clinics, imaging centers.
Two separate things. So the EMR client, they do healthcare, like chronic care management or something like that.
Yeah.
But they do come up with the care plans for their patients based on their symptoms and what have you.
Yeah.
And you did also mention that it does that as well.
Got it. Okay. So in that situation, it's different. In that situation, I don't know. We'd have to think about how we can do it. We can pull the data from anywhere. It's not hard. I mean, we've written plenty of wrappers. That's not hard to do at all, right? But to what extent we use it? Do we use it for training, or are we using it for predictions? Are we using it for operations? Are we using it in the clinical sense? We can pull it, but what we pull and what we really need, we would have to look at that in the assessment and try to figure out what we need for that particular use case. Because since you're on the consulting side of things, I'm sure you're tackling all kinds of operations, right, in consulting. So we would have to work with you and try to figure out how do we use it, in what sense. But I think generally speaking, we can integrate with anything.
Sure.
Does that answer your question? I'm sorry, it was a vague answer. I didn't mean to be, but
No, that's fine. Thank you.
broad for me right now without any context.
Bill, we have Mr. Khan.
Yes, Mr.
He's the
Khan, please
assistant, and
continue.
then we have a question on chat after Mr. Khan.
I'll get to Mr. Ali in a second, and let's tackle Mr. Khan. Yes, Mr. Khan.
Yeah, no, thanks, Anam, Bill,
Thanks,
for answering a few questions here. Yeah, I'm an early learner of AI, so I'm just asking common sense questions only with that stands on in my mind. So my understanding AI or AGI, I think it all depends on the size of data set. As you are looking at into various different verticals, as you mentioned, hospital is one of them and few other ones. How are you gathering that data set? I mean, the data set has to be huge to
So this is
be
an interesting
able to
question.
make these models to be very accurate or to be more
So
dependent.
it's a problem that's not understood by people.
Okay,
I
please.
just had a long conversation today with a number of physicians on this. So there's really four kinds of data. There's clinical data, meaning doctor's notes, patient history, drug history, medication history, that kind of stuff. There's clinical notes or clinical history, patient history. Okay. I'm a non-physician, right? So I'm going to say it in layman's terms, but hopefully the clinicians here will understand. Then there is diagnostic data, radiology reports, pathology reports, blood reports. Then there is, what was the third one, Simon? Then there's the diagnostic data, there is the clinical data, and then there was, the data at scale, the predictive data, okay? And then there is research data. Four kinds of different data. To a doctor, data is just data, but we were just having a very lengthy conversation about this morning. So we don't need clinical data at scale at all, actually. We're not trying to predict anything. The only time you need massive quantities of data is when you're trying to predict something, okay? Then you want to look for patterns. But when you want to do a diagnosis, you don't need massive quantities of data. The knowledge already exists in the systems. It can infer, it can reason the same way a human can. I mean, think about it. Does a human go to medical school for 12 years and ingest massive quantities of data? They ingest massive quantities of knowledge. So we treat knowledge and data differently.
Got it. Okay, so but again, just within the healthcare system, you already identify so many different data sets. But I understand for diagnosis, it could be easier.
Yeah.
But when you're running things autonomously, you're dealing with all sort of different unknown variables that you could be dealing with.
So it reasons it reasons through them like a human would. It just does it at scale. So in a clinical sense, let's just say you're in a hospital, you got to look at the workflows, right? And what all the workflows that happen in the hospital, some of them are clinical, some administrative, some are compliance, some are billing, some are, electricity management or whatever, inventory, ordering, procurement. There are many operations. Each one have different data. Whenever we need to predict something, that's when we kick off machine learning. Then we need big data. So we want to predict patient flows. Yes, we need massive quantities of data then. And the more data we have, the better we can predict patient flow. If we want to predict inventory levels, yes, we need big quantities of data. Give us more. We'll be able to predict out how much insulin you need, or when you need ibuprofen, or when you need, syringes or gauze or whatever, okay? When it comes to diagnosis for a physician, no, we really don't need much data at all. We just need to know what that current patient's symptoms are, any diagnostic reports, and just like a doctor, just looks at it, it reasons through a clinical diagnosis, and then it reasons through the best, most efficient treatment plan for that patient and moves on.
Okay, so that means besides the diagnostics and for the predictable workflows, then you can deal with that.
Yes,
and that's 80% of the work. And most only 10-20% could be predictive, and that you would deal with that accordingly over time.
Correct.
Okay, got it. Thanks.
Yeah, thank you. And for everybody, please remember, data is not the answer to everything. Okay. In fact, too much data, if given to the model, will actually bias the model. Okay. What I mean by that is, when the model is pure, when the pre-trained data, the pre-trained knowledge through all the language models, meaning the diffusion engines and the classification models that have the data, since seems to be a lot of clinical questions here, has all of the imaging data that it needs to know about every possible kind of cancer, for example, every kind of possible spinal abnormality or whatever it is you're looking at, right? It knows it. Don't tell it anymore. It knows what it is. Don't tell it more about chemistry. Don't tell it more about biology. Don't tell it more about the human DNA. It can reason from that ontological seminal understanding. It can reason to anything. Just like a physician can reason to anything, it too can reason to anything. So when you put too much data into it on top of it, all you're doing is you're biasing that model to reason down your thinking path. You're shaping its reasoning towards the way you, the human, think. And people have, different ways of doing things slightly. And so all you'll do is bias it, and you'll cause it to not come up with novel concepts or better or predict better things or look at people differently when treating them than, say, the conventional norms, and find things where we would have missed them. So don't throw data at everything. I have to often give a masterclass to people, even within my own company, is where data is good, where data is bad. And it's not just for medicine, it's in every field. So data is not the answer to everything. It is only when you're using a generative AI model. In generative AI, more data is good because in generative AI, in the transformer technology that is used in generative AI, the more data it ingests, the better it becomes at answering a question because of the way transformer technology works. So you give it more data, it's more effective in communicating with you. But that's it. Other than that, the only other time you need data is when you're doing machine learning, and that machine learning is only ever used for forecasting. When you start to tackle or start to wade around in the field of artificial intelligence, and you go into like chain of thought and reasoning models and theory of mind, that kind of stuff, then you don't want data. Now it's more sophisticated into how its neural networks work and deep learning networks or deep learning meshes work, and how you adjust the weights and biases in its neural networks, kind of like adjusting the connectors between neurons and the synapses, and how you get it to think. But thank you for that question. Okay, I'm a medical research environmental manager thinking how I'd be able to use the technology to expedite. Oh my God, medical researchers love it. That's an offline conversation about how we do research. Whatever you're researching, it'll help you in your research. Wherever you got blocked in your research, it'll break through. Even if it doesn't solve the problem for you, I promise you one thing. I've done this with cancer researchers. I've done this with Alzheimer's. I've done this with people researching like weird, bizarre laws. I've done researching things where people didn't come to a conclusion before. It will, even if it doesn't solve the problem for you, it will give you new ways to look at things that you never thought. And if you look at some of the biggest discoveries in the world, penicillin, Viagra, various kinds of things, they were accidental. The researcher was researching something else, and by cause and effect, they accidentally discovered something else. So even if we help you think through something else you never thought about, it'll take your mind down a very out the box, quote unquote, right? I'm throwing big fingers up here in the air. Let me show you my face. It'll take you through a very out the box thought pattern, thought path, reasoning path that you never thought about. And if anything, you may just get something new, some new insight that'll cause that breakthrough to happen. So I'm not saying it'll solve whatever your research problem. I don't even know what your research problem is, but I'm not saying it'll solve it. It may solve it. It solves, I don't know if it's solved, we haven't tested it yet, but it potentially solved early diagnosis of pancreatic cancer. But that was a rare incident where it just came right to the solution, bang, right there and then, right? Sometimes it'll just augment your research and take you down paths that you never thought before, but it's disruptive for research. The reasoning abilities are just disruptive for coming up with novel concepts. Saad Zarif, okay, good. Saad Zarif, by the way, is an advisor to our company. Saad, can you tell us about who you are a little bit? By the way, before we go to Saad, real quick, 1 second. Saad's internal. Any more questions? Thank you.
Yeah, I got it.
Yeah. Any other questions?
I got a point.
Yeah.
You are already into AGI. So my question is, are we really ready for AGI while people like Google's, DeepMind co-founder, I was reading his statement the other day, Shane Legg, he says in an interview that there's a 50% chance that AGI can be achieved by 2028. But your confidence says that we are ready. So I really need to understand, the industry is saying something else, but your confidence is next level. Can you elaborate how?
Sure. Are we ready? Is actually a little bit of context would have helped. Are we ready for it or have we achieved it? I think you're asking, have we achieved it, right?
Well, the industry statement is we are really not ready up until another maybe 10, 20 years.
You mean ready to deliver it or ready to deal with the cause and effect of what will happen to society when it's out there?
I think what it meant is when ready to understand the working of AGI, and let alone they're saying 50%. They're not even sure if this can be taken off. Yeah. So I want your expert opinion on this, please.
Actually, I will. Absolutely. So I don't know if you caught this part of the slide. Were you here for this section? Or did you join later? Were you here for the presentation?
Yes,
on this?
Yes, absolutely.
Oh, you did? Okay, good.
Yeah,
so first and foremost, let's talk about what AGI means before we start talking about whether it exists. There are two ways to look at AGI. In the behavior of the AI, in terms of the capabilities it exhibits, or in terms of the engineering of the AI and how they got to it. Please don't conflate the two. AGI engineering is AGI in the transformer architecture at the language model level. Let me explain. You've worked with generative AI?
Yes, I am. Yeah.
Okay. So when you prompt ChatGPT, you take a bunch of text, put it in a token window, shove it across the API, it queries a language model, the language model kicks off transformer, it outputs a bunch of text in a human readable format and shoves it back to you. Okay? That ChatGPT is going to the GPT 4.0 or 4.01 language model and coming out. So in that workflow, user's website, web page that you're talking to, into the language model and back out. In that workflow, it's very hard to achieve AGI there in that workflow, very hard. Because that means the language model, that one little component itself, that language model itself must exhibit these behaviors, these ones. In other words, GPT, the language model itself, must be able to broadly handle all kinds of tasks. GPT must learn everything while you're using it. GPT must learn in the background. GPT must exhibit reasoning. GPT must be able to perform any kind of task a human can do. GPT must be adaptable to how you use it. GPT itself must ingrain all kinds of ethics and safety, whether it's used in healthcare, or whether it's used in real estate, or whether it's used in Islam, or whatever. GPT itself must exhibit all of this. No, GPT will never do that, ever. I don't think they'll ever achieve it in GPT. Here's why. Because GPT, OpenAI's model, is designed for a business to consumer model. They're selling AI to you at $20 or $25 a month. If they were to bring this kind of behavior into the language model, and don't think it's not possible, it's possible, absolutely possible, just got to improve the parameters and improve the machine learning and make it continuous. If they did that, it's too expensive for the average user. Can you imagine? We've already got 500 million users. For every 500 million users, 10% of them started using it, they would go bankrupt. They're already bankrupt. And that's what should generative AI. So DeepMind may achieve it because they're not selling it to you. They're using AGI for search, basically, or research, basic Google search or research. So in a language model, will you achieve AGI? Probably not. And even if they do, it's not cost beneficial. You'll lose money. So you'll never see it at a generative AI language model level. However, having said that, is AGI achievable through orchestration? Meaning me as MindHive, the company, if I take multiple different kinds of language models, meaning multiple different kinds of knowledge bases, if I put on top of that continuous machine learning, ChatGPT is not continuous machine learning. They do transfer learning once every 6 months. That's why you keep seeing the version number upgrade. 3.5 to 4.0 was a massive upgrade in the training. It's transfer learning, not machine learning. It's not live, right? So I've added continuous machine learning into it. It's always learning. So that's how it's adaptable. So I use multiple kinds of language models. I do classification models, regression models, forecast models, diffusion models, and generative models. So I get all kinds of knowledge, multimodal. Then I'm continuously updating it so it's adaptable. I'm also making it context aware. GPT's context window is limited by the number of your tokens. So if you're just having a chat with it, it'll only remember as much as token window can remember. With us, it never loses memory. We're not limited by money. Our clients will pay hundreds of millions of dollars to run a hospital. So since we don't have cost of delivery to worry about, we can engineer a much more expensive system and make money off it because our customer is not the user. Our customer is a company that makes $4 or $5 billion a year in revenue, and they can easily afford to spend 500 million, 10% of their revenue on AGI in their hospital because they'll save $2 billion in costs. So you take a company that's doing 4 billion in revenue, let's take Medical Park Hospital System, Live Medical Centers, Turkey, for example. It's about $4 billion company annually with their affiliates. Of that $4 billion, $3 billion is operating overhead. They're running at a 20% profit margin, 25%. Now they're burning through $3 billion of cash every year. Now, if they were to spend 1/10 of that, $300 million a year to automate the hospitals, and they can save $1.5 billion, half their costs, of course they're going to use it. And so AGI for me is not hard to achieve because of my business model through orchestration. Orchestration of these various elements.
Can I say a few things?
Of course.
Well, as much as on a lighter note, as much as I love your deliberations and connotations, your sea of rather ocean of knowledge, but sound like you don't really like Chat GPT.
Beg your pardon, I don't like ChatGPT?
Yeah, I mean, you referencing them in every...
Because, no, I love it. We use it all the time. In fact, it was ChatGPT to a little of the early beta version of ChatGPT. Actually, it wasn't ChatGPT. It was the early version 3 years ago of OpenAI's language models in Azure that I started using about 3 years and 4 months ago. That's how I learned a lot about how the neural networks work. I actually love it. I use it all the time. But in an autonomous system, it can't work. And what happens is if I don't educate on the differences between generative AI and these kinds of AI, people at large won't understand. So if I don't explain the differences between reactive AI, explainable AI, deep learning, theory of mind, general adversarial network, if I don't explain that to people, then they assume by default all AI is generative AI. I'm not trying to say ChatGPT. There are many generative AI tools out there, and they're all really good for their own use cases. Jasper.ai, for example, is an incredible tool for marketing. We use it internally ourselves for marketing, and it's all generative AI. We use Hootsuite. Hootsuite is a lot. We use that internally for doing social media marketing at scale. We use AI in Copilot within our company. Copilot is surfacing our entire network, and we use generative AI for that. And that's based off the GPT model. We use HubSpot for our CRM system, and we use generative AI in there to score our leads. So it's not true to say that we don't like generative AI. We love generative AI. We use it all the time. But its purpose is good for generating content or analyzing text-based data. In that use case, it's the best. I would never reinvent that. But you can't run a hospital on generative AI. And our job, what we're trying to do, is we're trying to bring autonomous AI to industry. So we have domain-focused models. So if you go look at our website or you talk to one of our clinical staff or our legal staff or our real estate staff, you understand that our models are domain-focused. We're trying to build autonomous systems. Kind of like Tesla, where Elon Musk did for a Tesla car. In that use case, of course I can't use generative AI. The Tesla car doesn't use generative AI. It uses all these other forms of AI here. So I'm not dogging GPT. I love GPT. It's actually very, very effective for what it does in terms of transformer technology. But I can't run businesses on it. And I can't solve cancer with it or do other kinds of things.
Bill, we have a question in chat.
Yeah, 1 second. No.
Thank you, by the way.
No, you're more than welcome. Thank you. I didn't mean to dog GPT. I actually have massive amounts of respect for Sam and the team there. Okay, thank you all. I want to mark. Okay, I don't see the question. I see it. Oh, is this Noman Khan's question? Okay, great. Thank you for all this information. I own a marketing agency. I've started using AI tools as an admin assistant, still trying to figure out utility, market, advertising. Any thoughts? Okay, great. Yeah, so I just mentioned three tools. Two for marketing advertising. I mentioned Hootsuite and I mentioned Jasper.ai. Fantastic tools for marketing. We use it all the time. A lot of our blog posts we do are either done through GPT or through a tool built off of GTV, which is called Jasper. If you haven't used it, please take a look at it. They just got a massive valuation. Their customer base is exploding. Marketing, Jasper, amazing. Jasper will do your entire brand campaign management. It'll do your brand kits. It'll write your content. It'll build your websites. It'll do blog postings for you. It'll even do audience segmentation for marketing. Let's just say you want an audience to, I don't know who the customer is, but you want an audience to, I don't know, people who like ramen noodles in Orange County. It'll do your audiencing for you. It'll analyze your metrics for your ads and tell you if you're getting good results or bad results. It'll help you build ABC, ABCD tests. So everything you do in marketing in terms of at least digital marketing, fantastic for it. Love it. Use it all the time. In terms of other forms of marketing for social media marketing, Hootsuite is an amazing product, HOOT. So the first one, by the way, I'm putting the text message, is Jasper. The other one is Hootsuite. Hootsuite is like an owl. It hoots. And it connects to multiple social media platforms, Twitter, Instagram, Pinterest, LinkedIn, Facebook, I don't know, everything. And you can go into this Hootsuite's tool. I'll actually show it to you. You'll love it. It's great. We use it. Let me show it to you. And if you're in marketing, I'd like to help you market. So I'm helping some companies in Pakistan, actually, through an incubation thing that I'm doing. And I'm actually showing them how to market because, unfortunately, I think a lot of these small business owners aren't growing because they don't know how to do sales and marketing. So I'm actually showing them Hootsuite myself. Here, let me show you Hootsuite. So this is Hootsuite. It's coming up on your screen. You see this? So this is Hootsuite. And if you want to create like generative AI to create content at scale, you go to create here, and it says content with AI. And you click that, and it says, you want to repurpose your top posts. It'll go scan your social media, take your top posts and repurpose them for you. Start from scratch, come up with new ideas, turn web content. So let's start from scratch. That will actually create marketing campaigns. But let's just say get inspired. What do you want? What topic do you want ideas for? People who don't believe that AGI exists. That's the topic, okay? Can't see it in my screen, sorry, okay. There you go. So let's go ahead and create some content around this topic. Get ideas. Good. The psychological impacts of disbelief in AGI, historical context, the role of media representation, cognitive biases. Let's pick this one. Great. It's going to create the social media post for you using generative AI. Done. I like it. Create post. Creates the post. Pick the social media accounts that you want to use. DV8, Mindhive, me personally, my Facebook. Add tags. Boom. Post it. Mass. Done. Schedule it for later if you want to. Another great use case for marketing in AGI. And there's Jasper. I can go into that. Then there's HubSpot and so on and so forth. So for a marketing company and you really want to scale marketing, fantastic. Generative AI is probably exceedingly productive. We can do content marketing at scale. We also use tools like Synthesia to create videos. Let me show you guys. Well, I'll show you later. Somebody post our YouTube channel, please, out there and let them see the videos. That's all AI powered. We've created some incredible videos. You wouldn't know that AI created it. You'd think that a human did that. But it was all AI powered full motion videos, as long as I think some of them are 6 to 9 minutes long. We can create content at scale, full motion video for advertising and promo stuff. In fact, there was some Arab kids here in Fullerton that have a little tiny marketing agency, and they were spending all this time in Adobe editing video. I'm like, what are you guys doing? I showed them how to use Vid.io, and they're like, what? I can make a 10-minute promo video? I said, yeah, just write a script. They're like, it takes time to write the script. I showed them to use ChatGPT. I showed them a ChatGPT to define a product. They defined the customer's product in ChatGPT, and I told ChatGPT to output a video script that promos the product. ChatGPT outputted a 6-minute video script. They took that video script, copied and pasted into Vid.io, and made a movie and published on YouTube. And the customer's happy. They got paid, I don't know, $500 for it or something. So great use case for ChatGPT. Wrote a whole video script for them. Somebody give Mr. Khan a link to our YouTube channel. I think we've only got like 4 or 5 videos up there, right? And we just started using promo videos. If Aisha Nadeem is here, she'll do it. If not, please send us your email address, Mr. Khan, and we'll send you our YouTube link. Otherwise, we'll post it in the WhatsApp group for Mindhive. Sylvia?
Yes, Bill.
Please give Mr. Khan your email address and my email address privately.
Sure, absolutely. I'm posting it again here.
No, that's the YouTube video? Great. Actually, let me bring it up for you. I'm going to show you a video, okay? You guys won't believe this when I show this video. You won't believe this thing was created with AI. I mean, maybe you will. For those of you that use it, maybe you will. I don't know. But most people don't know it's done by AI. It's amazing. Well, the wrong one. Hang on a second. So for the marketing guy out there, take a look at this. Okay. So you see these 3 videos? This one was created by AI.
Welcome to Ava Healthcare One, where advanced technology meets compassionate care. Here we are.
Okay, so this is one. Okay. Now look at this one. Okay.
Imagine a future where patient diagnosis and treatment are powered by artificial intelligence, an autonomous system that learns, adapts.
That was AI created.
Every.
This was created by AI.
Welcome to our exploration of how MedOps AI could revolutionize healthcare in the future.
So for the marketing guy out here,
Fully autonomous hospitals.
for the marketing person,
Facilities are
we'll show you
to the exciting
how to
potential of
use AI to basically create all your content. And if you want to do multimodal content, videos, audio, we'll show you how to use AI. Just ChatGPT will show you how to do it. To how to use AI to create the video scripts to basically define your customer's product correctly according to the sentiment of the audience. Write that content script for the audience for that product. Output a video script. Take that video script, put it into another tool, and generate a video like we just created. And all done in about 20 minutes. Less than that. Okay, thank you, Ali. Appreciate that. See, I'm not against ChatGPT. I love ChatGPT. It's very productive. Any other questions? Sylvia, do you want to wrap it up? Looks like we have no more questions. Okay, thank you, Mr. Khan.
Okay, great.
Thank you.
Is going to be there in about. Naman Khan is going to be there in about. What was that, Simon? I think it's Naman. Simon was saying something. Naman Khan, not quite sure. Okay. Thank you, Bill. Great presentation. Thank you, Mr. Ali. Appreciate that. Again, I'm always open for questions. Just I don't typically give my email out like this, but if you please route through Simon or Sylvia, something will get back to me. I will be traveling for the next 3 weeks, so I may not be able to respond. But when I get back from Turkey, I think I'm going to do another one of these again.
So Bill, if you have a couple of minutes, can you just describe what you're doing in Pakistan?
Sure.
I know you're setting up things, and just give a little summary on it. I heard about it on Sunday, but I would love to hear it more.
Yeah, so we're just moving all of our engineering to Lahore in Islamabad. Instead of doing it in America, we're going to do it there. Not necessarily for cost efficiencies, because I pay US salaries, even in Pakistan. So I'm not trying to take advantage of the economic disparity. I was approached by the Pakistani government in the summer to bring this AGI technology to the country and run an innovation hub. And so they made me co-chairman of the Pak American Tech Council to kind of like, I don't know, be that tech entrepreneur, but not get married to any other organization, but just do it in Pakistan. So I made a commitment to the country in the summer, and they got behind me and they helped me. We didn't take any money or anything like that from it at all. In fact, we committed to investing 10 to 12 million next year and hiring people. We're currently hiring about 5 people a week in Lahore right now, and they're all engineers, and we're training them. And we use our own AI actually to do our engineering. So we're teaching how to use it in Pakistan at scale, right? Not just our own employees, but other people too. So we're trying to improve employment in some way if we can. But as I told during the conference, I don't know if you were there at Stanford when I spoke, but somebody asked me.
I was there, yeah.
Right. So I think Dr. Sherwani asked me, and I said, I'll never be a 300,000 person company, right? And if I am, that means I'm not using AI right myself. But we don't think we're going to have much of a dent on the economy ourselves per se. And I don't think we're going to change unemployment anyway. But I think by our presence being there, through some of the R&D we're doing in AGI and bringing this kind of awareness to the country and helping people out of that, I think they'll start businesses, kind of like we're helping this person over here in marketing. There was another company we're helping with law, another little company we're helping. I started speaking to where they're using generative AI for agriculture. We showed them a better way to do it. And so we just bring some thought leadership there and effectively basically move all of my engineering and all of my R&D to Lahore.
So just in that, how are you finding the candidates there? I mean, do you interview them remotely or?
So I was running out of our own ability to do it. So we gave a contract to a company called HR Pod, and they've been really good so far. We were doing LinkedIn ads in Pakistan, getting a bunch of emails in, but it was hard to scan them and filter them in Pakistan. We actually use AI to stack rank ourselves. Generative AI, actually, GPT.
Good.
We do it to stack rank. So
Excellent.
We'll take like 100, 200 resumes at a time. And we'll go to generative AI and we'll say, read all the resumes. And based upon this job description, who do you think is the best? And that actually Ava does that. So our AGI agent does that. She does use generative AI to read it then. And so we'll ingest resumes at scale and then stack rank 12, 15 people out of it and then try to interview those. But it was getting to be too much with LinkedIn. So we outsourced it to a recruiting firm in Karachi.
Great. So by the way, at Stanford, we visited the lab T-Lab together. You remember?
Yeah. That's right. That's right.
Yeah, this is Anwar.
Hi. How are you?
Yeah.
Sorry, I remember you.
No, Walaikum Salam. So, but just last question: incubation center. You mentioned you're starting incubation place as well. Any effort in that regard, or when would that be?
I just announced it last night. The consul general at his house. I was over dinner, and he said, "Any other good news for me?" As I was leaving, I said, "Yes, I promise you, I'm going to start an incubation lab in Lahore." And he said, "Will you be bringing funding?" I said, "Not me, but I will encourage other entrepreneurs and my friends and some other people with some high net worth to seed these companies in Pakistan if we can." They don't have a big cash demand, right? It's not like America where you need $100 million. You know, if you give these entrepreneurs $100,000, that's a lot to get them going, right? Especially the cost of labor there. So, you know, small amounts of micro funding, if I can help that way. For example, yesterday, an entrepreneur called me and tried to cold call me and sell me. And I thought he was some Indian company trying to sell me. And I was like, I was going to hang up the phone on him. I said, which part of India are you from? He goes, I'm from Lahore. So I said, यार तुम्हारा दिमाग खराब है, तुमने चेक नहीं किया कि किससे बात कर रहे हो? I own a company, यार, I compete with you. क्या कर रहे हो तुम? So he's like, मुझे क्या पता? So I said, yeah, this is the kind of thing that needs help, right? People don't know how to sell, they don't know how to market correctly, they don't know how to do diligence.
I really like the idea of incubation lab for AI.
So mentorship, really,
Absolutely.
what I'm bringing.
Absolutely.
Inshallah.
Good. Thank you.
Yeah. But yeah, if you want to join me with that, please join me. I can use all the help to mentor some of these kids and these business owners on how to sell, how to market, how to position themselves, how to scale, you know, how to achieve product market fit. A lot of these guys don't understand USP, minimum viable product. They don't. I mean, they were not educated overseas or weren't exposed to Western concepts for tech. And when you ask them, what's your USP? You say, how did you achieve minimum viable? Don't know, right? Or even when they do, they know it from a textbook. They don't really understand what minimum viable product means. They don't understand product market fit.
Absolutely.
So they want
to we are doing a series on that as well, teaching them on the entrepreneurship side of things, the whole cycle of A to Z, including the product management. Yes, last night was a product management course there.
Good. That's the kind of stuff.
But then also we've been teaching generative AI to thousands of our young and professional people, so that they can start using existing models and turn them into applications. So
there was a lady, Dr. Saima Hassan. I think she's a PhD. She's a teacher, high school teacher in Quetta. She wanted a job. I had no role for her. But she said, I said, what are you trying to do? She goes, yeah, I need to teach these children content, and I need to work with you guys so you can guys help me create some content. So I showed her how to use ChatGPT, just in a call with her in Quetta.
Exactly.
And I showed her how to use ChatGPT. I think I even gave her a free license. I think we're paying for a license, $30 a month. I just gave her a free license. I said, "Isko use karo." And I showed her how to use ChatGPT to put the profile of all of her students into it, to describe her profile, right? They were like children between 12 to 15. So she put the profile, the gender of the child, the age, any knowledge about the child, the subjects the child was interested in, and any other things that basically context about the kids, right? And so she created a portfolio and a spreadsheet of what these children look like, the demographic of these children. And she put that spreadsheet into ChatGPT and said, now, based upon this spreadsheet, can you tailor for each child a curriculum for, I think she did, I don't know, she might have done English or something, or chemistry, I forget, some subject. And she was able to quickly output, training material, coursework, that was uniquely designed for each child.
Absolutely. I think this is how we are teaching as well, these generative AI, that how you can use ChatGPT, whatever the problem they want to solve, they give to ChatGPT. This is where you have identify existing model.
Yeah.
And once they identify the existing model, to write the code for that. So it can run on Google Colab.
Yeah.
And it's just, I think, in a few hours, they are able to have the whole application running. And that's what we are teaching. It's simple things, but how very powerful.
So I give ChatGPT free to anybody who asks. If you ask any one of my company members, I give ChatGPT. We have enterprise license with OpenAI right now. And anybody asks for it, the only thing we request is that they use a DV8 email account, because we have to be able to manage the licenses. But they can't log on their Gmail, but we give it away for free. And we give all of the AGI agents.
Any limitation on numbers? How many people?
No, makes sense.
It could be in thousands?
Could be in thousands.
Excellent. I take that offer, by the way.
Yeah.
Right now we have taken the third cohort to Pakistan Engineering Council.
Yeah.
So under their name, they're offering my course to. So there are about 12,000 people have signed up from Pakistan Engineering Council right now.
So if we're going to buy in bulk, OpenAI under our enterprise licensing agreement, when we buy in bulk and provision in bulk, it's basically a logistical challenge. So we'll have to figure out how to do it in bulk. The maximum.
No, I think this thing we just need for people to get trained themselves, right? And they want to work on 4.0 rather than 3.5. So they can use it better. So that's the whole.
So one other thing I'd like you to know, and everybody's listening, if it's a doctor and they're treating patients and they're not going to use it for commercial gain, I give Chiron for free also. I don't charge physicians for it free of charge. And because I want them to learn how to use it properly, because it is AGI, it takes some skill and they get confused. And I have a lot of challenges with clinicians on how to use it correctly because it's unstructured. So we're building a user interface for physicians to give to free. To give them for free, it's a cognitive user interface. It uses generative AI actually to morph the user interface based upon the field of medicine you practice. So if you're an oncologist, the workflows are cancer related. If you're a pediatrician, so I'm going the process of building an internal user interface that will then turn out to be a polymorphic user interface for physicians. And we again will give it to them for free. We're not charging the physicians for it, but it's ChatGPT to a small business owner or entrepreneur, not a student, but a small business owner in Pakistan. If they actually can demonstrate they're a small business owner or they're going to try, it's available for free to them and all the employees. Okay, no charge. If they're a medical student, available for free. Dow Medical College, where I'm speaking there when I go to Karachi in December, Jannah Sindh Medical University, IBA. We're currently working with these universities for free to the students, if they're medical students. Because I personally believe that.
How about, I think I have an initiative called Park Angels, right? We help startups as well. One of the startups is Easy Shafa.
Yeah.
So they provide the remote diagnosis to poor people, right? From kiosks.
Yeah.
Can they have access to that as well? And,
I should think so. Saima, we should, Sylvia's saying we need to close at 5 o'clock, but Saima, I think you should definitely talk with this gentleman and tell them about what all the initiatives going on in Pakistan and what else we're doing. So you can kind of either align with something we're already doing, or if this is something brand new. I mean, to us, this is philanthropy because it's donations. We're not making any money off it. So it falls under my philanthropic efforts that we have for MindHive AI. And so we just need to make sure we prioritize our money right. But yeah, I think we're definitely open to it.
So I just sent my email again so they can follow up on that thing. Yeah. Okay.
Okay. And the last one. I'll leave this for Mujtaba Ahsan and Mohammed Anuka. Good. So Saima, Sylvia, somebody please take Mr. Khan's email address and get back in touch with him. I'm in Pakistan from the 15th of December till the 6th of January. I'll be speaking at Apna, Dow, Jannah Sindh, Indus Hospitals, IBA, and then a few other places in Lahore. I'm not sure where. I don't exactly have my calendar, but if anybody's there in Pakistan wants to meet with me, just round robin and Sylvia, I'll be happy to come out and meet with you guys. Mujtaba Ahsan, thank you for doing this session. I'm an entrepreneurship professional at San Diego State. I'm doing research with AI and organizations. Found this session very informative. Let me know if I could be of any help with your initiative. Thank you, Mr. Ahsan. Sylvia, please grab Mr. Ahsan's email address. Let's bring him into the group also. Anybody who's working with it, we want to, keep scaling, right? And then finally, I know that Mr. Zarif, so by the way, for Ava Healthcare, which is a subsidiary of MindHive, okay, Ava Healthcare is the subsidiary of the AI company, the parent company, that only focuses on healthcare through MedOps. Ava Legal is so everything is, every model we have is named after Ava, okay? So Ava Legal, Ava Healthcare, so on and so on. So Ava Legal is for law, Ava Healthcare is for healthcare, and so on and so on. So Ava Legal gives birth to this MedOps autonomous AI systems for hospitals, using all those tools that we did. Saad and Ali work for a private equity firm that's doing a capital raise for $100 million right now for Ava Healthcare to power all these MedOps initiatives we've got around the world. And so I believe they're opening right now. Saad, tell me, I'm not quite sure what you're doing in terms of the raise. Exactly what are you guys doing?
Yeah, sure, Bill. And it's been an amazing session. Again, I think you've done 2 back-to-backs. Mashallah, you've got amazing stamina for doing this, which is great to see. So my name is Saad Zarif. My co-founder Ali Faruki is on the call here. We run a wealth management and private equity firm out of Southern California. So we are leading the round for Series A. This is all well and great for everybody to learn and throw their ideas, but you need the right funding to make this work. That's what Sam Altman is doing with OpenAI. That's how Tesla grew the way it did. They came up with the ideas, they build the relationships. Now you need the funds to make it grow and get to the next level. That is what we're doing. We've just opened the funding round for Series A for people that want to get involved directly into Ava Healthcare as an owner, basically. So you get a certain number of shares allocated to you. Both myself and Ali Farouk are leading that round from our end. What we want to do is for you to reach out to us so we can vet you, make sure you're an accredited investor, that you understand what this will take for you to get involved, and then help you kind of get involved on an equity level, basically within Ava Healthcare, and make this reach the next level. So it's pretty much a 30-day round. We have a lot of interest. A lot of people are interested. So we expect to close this round in December. For sure, inshallah. And for those of you who are interested in any capacity in getting involved in supporting Bill and his team, at the same time, if you have the resources to fund the Series A round as well, it's a great opportunity to take advantage of that. So we have the funding round available. We will provide you a pitch deck on it and do a one-on-one call, tell you more about it, and then get you started in that. So please send us an email. My email and my partner's email, Ali Farouk's, is there in the chat. Make a copy of it, shoot us a message now, and we will book time with you either tomorrow, over the weekend, or early next week. We're working around the clock for this, for the 3 series round, Series A, B, and C, to reach $100 million target for Bill and his team to achieve whatever it is that he has talked about so far.
So a little history about how we got Ali and Saad in, give you an idea. So I was speaking at UPNA conferences left, right, and center, and university and stuff, and a lot of physicians wanted it, but it was cost prohibitive. Couldn't give it to them. So I wound up giving it to them for free. I just said, okay, take it for free, right? But then they wanted it more in an industrial strength way, right? And they couldn't afford it. So in some of my conversations with a lot of the physicians in San Antonio, and then in LA recently, and in Dallas, Washington, DC before that, and not just the UPNA physicians, but Imana here, and various emergency rooms and other doctors, right? Because they knew how disruptive this was for healthcare, and they've tried and tested, they loved it. So I said, look, if you guys got together and pooled your money together, I suppose you could probably afford it for like this group of internal medicine physicians that wanted it, or these interventional cardiologists wanted it, or radiologists wanted it. So then they started pulling them out. They started getting together, and they started coming to me and saying, okay, we're ready. And I didn't have the bandwidth, we're an engineering firm, man. We're not investment bankers. We don't know what we're doing in this space, right? So we decided internally to put a private equity fund together. And then my chief operating officer, I tasked Jim Barry to do that, who may or may not be on this call. I said, Jim, you handle him. Jim's like, he got overwhelmed. So I happened to bump into Ali and Saad somewhere, and I realized they were registered investment advisors, and this is what they do. And I said, guys, this is the demand we've got. I can't organize all this capital. This is a self-funded company. I've built the AI. That's my money, my personal money I've used, out of my pocket, no investors at all, fully self-funded. And I'm going to continue to do MindHive AI. But for the small business owners, or the micro owners, sole practitioner physicians, or the small business owners, 50, 60, maybe even 100 physicians, I can't surface this demand. So if you guys go out there and you talk to these people, then maybe you guys can put these special purpose vehicles together and pool the capital together just for healthcare. I don't need it anywhere else, just for medical, for the small business owners. We're still targeting the large hospital systems, and they're our target market, and they'll pay for their own systems. But to be able to create these kind of SaaS-based offerings, we need funding for them. I can't finance every single internal medicine physician in the world, or every single oncologist, or every single cardiologist, or rheumatologist, neurologist. I can't do that. So they got to put their money together and do it if they want it. So they said, yeah, we'll put the special personal vehicle together. And so we estimated to be able to service America alone, we would probably need about 100 million over the next 12 months to be able to build out these systems so we can turn around and lease it back to those same doctors. And then also give them the ability to earn dividends off of, the product around the world. So they get to earn off of the revenue of their own product they created and that they're using. And so Ali and Saad said, look, we'll put this together for you. And that's kind of, we said, okay, fine, let's just do it for the healthcare model, nothing else. Well, MindHive is fine. We're good to go there. We don't need money there, but for the healthcare systems, go ahead and raise the money. And that's what brought this on. And that's why they're here.
All right. Great. Thank you, Bill.
Yeah.
I don't think we have any more questions. So we'll be closing. Once again, thank you everyone for attending the session today. We really appreciate the questions and all the participation. We'll be hosting more webinars like this in the future, so please keep an eye out for our invitations. And also feel free to spread the word to others who might benefit from joining us. Thanks again, and we look forward to seeing you all next time. Have a great evening, everyone. Thank you.
Thank you, everybody. Thank you very much. Appreciate it. See you guys soon. Bye-bye.
Bye.
Bye.
Bye.